welcome to Algebra 2, Lesson 2-2, standard form of quadratic function. So example 1 is about finding the vertex of a quadratic function in standard form. So we're going to think throughout this lesson about the key features we can determine about quadratic function from an equation in standard form. So first of all, so the standard form of a quadratic function is y equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0, because if a were to equal to 0, then it would not be a quadratic function, it would just be a linear function or just a constant function, right? So it could be any number except a is 0. So we're going to use this form a lot, but we're going to also use vertex form to get the standard form. Okay, because if we have a vertex in another point, it's really easy to write an equation using a vertex form. But after that, we can write it as a standard form and change it. Right? So how could we find the vertex of a quadratic function written in standard form? So if we see an equation, a quadratic function in standard form, could we find a vertex? Yes, we can, but how? Okay, so first of all, let's look at the vertex form. If we change this vertex form into the standard form, we'll have ax squared minus 2ahx plus ah squared plus k. Because if we square this binomial x minus h, then we have x squared minus 2hxh plus h squared. All of that multiplied by a. So if you do that, you'll get this form. So your h and k are there, but you have to figure out which numbers are which, because a and h are mixed here, and then we have a k here, and then a is here. So we can see that a is by itself in the coefficient of x squared term, and then k is the constant term, right? So if we see any standard form of a quadratic function, check what a and k are, and we can easily identify that. And so if we divide a on the second term and the third term, then we can get h, 2h, and h squared. Okay, does that make sense? So yeah, keeping that in mind, let's also look at this equation. Okay, the vertex is h comma k. So in order to get the x coordinate, which is h, we can say that b would be negative 2ah in the standard form, right? So ax squared plus bx plus c is the standard form, but b here will also be the same as negative 2ah, because if we solve the vertex form, we'll get negative 2ahx. So b is equal to negative 2ah in vertex form. Okay, so you don't have to memorize all this. If you know the vertex form and you know how to solve it, then you'll be able to figure that out, right? So it's all about understanding. Let's look at part B. So what's the vertex of the function of this? So this is an example of how we could find the vertex that's already written in standard form. We don't need to change that to a vertex form, but we can figure that out by this equation, h equals negative b over 2h. Okay, so remember, a should be the coefficient for the x term. So a is 1, and then this should be k, because the constant term is k itself. So then the second term, which has an x in there, oh, the last term, actually, the constant term is actually not just k. So ah squared plus k is equal to 10. Never mind, so sorry. Okay, so that is c, and your a is just a. A is the only one that's a. Okay, and then negative 6 is going to be your negative 2ah. So let's write that equation. Negative 6 is equal to negative 2ah. So we have a system of equation, right? negative 6 is equal to negative 2ah, and ah squared plus k is equal to 10. And we also know that a is equal to 1. So if we plug in all these numbers for a, then we get the equation negative 6 is equal to negative 2h, and that's just h squared plus k equals 10, right? Yeah. And we already know that h is going to be negative b over 2a because b is equal to negative 2ah, right? So yeah, in order to wait, is this negative? Yeah. So yeah, in order to solve for h, we're going to change this into h is equal to negative 6 over negative 2 by dividing negative 2 on both sides. And so h is equal to positive 3. And then you can just plug this in. Now that we know h, 3 squared plus k is equal to 10. So k is equal to 10 minus 9, which is 1. So your hk, which is your vertex, would be 3, 1. Okay, and then now we can say, oh, we figured out the vertex. And we can easily write this in vertex form as well, now that we have all the pieces. Okay, so yeah, there we go. So that's how we find the vertex from the standard form. It does take some time and you need to solve for the equations. So it's not as easy as finding the vertex from the vertex form, because in the vertex form you can just easily see it, but in the standard form you have to solve for it. So let's try number 1. But you can solve for the vertex, right? It's not like it's hidden. You just have to solve for it. So what is the vertex of the graph of the function f of x equals x squared minus 8x plus 5? So pause the video and see if you can solve it by yourself, and come back when you're ready for answers. Okay, are you ready? So follow the same steps, okay? Right? So notice that we have this equation h equals negative b over 2a. Again, if you don't remember why or how this equation is there, you can solve your vertex form into the standard form, and notice that you have the second term, the coefficient of the second term would be negative 2ah. So your h is simply negative b over 2a. Okay, and then this, your a is equal to 1, and then your b is equal to negative 8, c is equal to 5. And remember that your c is also ah squared plus k. So writing that down, you can figure out the two equations. So write whatever you already know. So a we know, and then b we know. So h is going to be negative 8 and then negative over 2a, which is just 1. And c is equal to 1 times h squared. So h squared plus k. Okay. And then we can first solve for h. H is going to be positive 8 divided by 2, which is 4, right? And then we can substitute it right here and say, oh, 5 is equal to, because c is 5, is equal to h squared, which is 4 squared plus k. And so your k is equal to 5 minus 16, which is negative 11. So now that we have h and k, we can write the vertex as 4, negative 11. Okay, so that is our vertex by the standard form, x squared minus 8x plus 5. So that was example 1. Given the standard form, can you figure out a vertex? So we'll continue with example 2, graphing a quadratic function in a standard form in the next video.